conversation.
Which doesn't work. I mean, well, it's marginal.
It's clear location.
Well, good. Somebody else
know
had to
who you
script
are, right? You
themselves
can
too,
introduce yourself.
I wish I could whistle. Whistle? Say, folks, recess is over.
You have to be like Chris Christie. Sit down, shut up.
Yeah.
We need a gavel.
So we're going to welcome panel 2, same sets of rules, so we won't go over that. Focus on this panel is around system information and what kind of data and information bulk we have available in the system that we need to make available and vehicles to do so. So Michael Warden, who is the Deputy Director of our electric division, is moderating this panel, and I'll let you, Michael, start with introducing the members.
Okay, I think I'm going to let the panelists introduce themselves just in the interest of time. One thing I've asked them to address in their initial comments is, you know, not only what do we need to foster this market, but what we need to do to ensure reliability, because at the end of the day, that's something we have to do. So without any further ado, I'll turn it over to Kevin Cushman.
Great, thanks, Mike. Chair Zibelman and Commissioners, appreciate the opportunity to represent Integral Analytics, my company. And where we position ourselves is a little different than the traditional stakeholders that we've heard from in Panel 1 and I think in Panel 3. We're really an enabler to what ultimately REV will look like down the road. And where we find ourselves as a grid analytics company is trying to break information out of different silos from the different stakeholder groups. So if you think in terms of distribution planning, the distribution utilities, what they need and their stewardship is essentially reliability, as we've discussed, and everyone in the room knows that. But how do you merge the reliability requirements of managing, planning, and setting aside capital against a system that's evolving in the way that the vendors on the DER side, as well as customers, would like to see it occur? And so what we look at is trying to create a data architecture, in essence, using the data sets that are already in use for ultimately siloed purposes now, and merging them to create an opportunity where at the DSP level, as been discussed earlier, the DSP can act as a clearinghouse, not just as price signals, but price signals matched with reliability components. And we'll cover that hopefully in the Q&A. But what I'd like to leave you with as a first comment is how we look at the DSP and ultimately what we call distributed marginal cost. And distributed marginal cost we view as a metric that ultimately combines the varying individual data sources and reliability pricing, not at an average avoided cost level, but at a distributed actual avoided cost level. And by that I mean starting with geospatial load forecasting, moving that down to an individual zip code, acre, circuit level, understanding what's moving load from an econometric modeling perspective on a customer level, but then washing that against power flow modeling tools that have traditionally been siloed in the distribution planning environment, supportive of IRPs. So we like to say we're merging what essentially drives customer choice and the IRRs for DER vendors with the constraints associated with managing a reliable system and maintaining power quality and all the components associated with distribution planning. So visualize a 4-quadrant system where you have grid and supply, variable and fixed costs. Each one have definitional components, and each one of those components has essentially a coefficient in a statistical sense. And that coefficient could be 0, where you have overcapacity. It could be a significant coefficient, all driving to an equation that at a substation, a load bank, or a circuit level creates an opportunity to create a market clearing price and a price signal that vendors and utilities are comfortable generates the outcomes they both want to see.
Good morning. My name is Tony Shea, and I'm with Silver Spring Networks. I'd like to again thank the Chair and the Commission for the opportunity to make some comments on the proceeding. Just quickly on Silver Spring Networks, we deliver open standards-based networking platforms, software and services to major utilities and cities worldwide. Basically to support smart grid and smart city applications on a single unified network. And you'll probably hear that as a kind of a recurring theme in some of the things I talk about today, that the base network is important to enable some of the things that we've heard about relative to DSP and REV. These core platforms enable utilities to improve energy efficiency, enhance services, again, such as we're talking about today, but ultimately to reduce costs overall in terms of that baseline investment. We've been providing these types of platforms and solutions for over a decade. We've recently passed our 20 millionth endpoint deployed globally, and have a lot of referenceability in the market relative to how multiple applications can play on top of a common core framework. So that's the commercial for Silver Spring. That's over. Relative to what we think is necessary to enable DER and the critical success of it long term. We think that vendors will need data from a variety of sources, have access to that granular data from the grid as well. The data will need the ability to flow both upstream and maybe even peer-to-peer to make better decisions, so the market can react quickly, and folks don't find that, or the system doesn't find itself in kind of a stalled state. The regulatory framework will play a very key part in assuring that those elements work correctly, that systems can interact seamlessly from both the head-end system all the way to the edge. In closing, kind of safety, reliability, security, both cyber and data otherwise, is extremely important. We see this across our customers and in various jurisdictions, not only in the U.S. but around the world, and it is a very key concern. So we're sensitive to that, and we've built some solutions that take that very seriously. So, that said, the underlying network will unlock the power, we believe, of the service that needs to be provided for DER in an effective and also a very future-proof manner. So thank you.
Good morning. My name is Stephen Wemple. I'm Vice President of Regulatory Affairs for Con Edison Solutions. I'm actually here on behalf of the Retail Energy Supply Association, which is a trade association of 21 entities selling electricity throughout New York State and to customers in 16 states throughout the country. Before getting into the issue of what system information do we need to promote distributed energy resources, it's first worth touching on the existing information and price signals that are out there that customers and service providers are already reacting to and working with to deliver distributed energy resources. The most obvious of which is the wholesale market signal, the capacity and energy prices that vary locationally and by hour. And in response to those price signals, ESCOs like the RESA members are providing hedging services and products to customers to meet their commodity needs. In aggregate, based on Commission statistics, 1.7 million consumers in New York State have chosen a competitive ESCO. That represents more than half of the electricity delivered in New York State. So obviously a logical starting point is with the commodity ESCOs, many of whom already provide energy efficiency, demand response, and renewable products to their customers. In the case of Con Edison Solutions, a utility affiliate, we've been providing that for over 15 years to customers in New York State and in New York City. Aside from that shameless plug, the other price signals that customers do react to are the traditional utility, the demand charges, and the on and off-peak volumetric rates. Customers with service providers have come up with demand limiting strategies to control their energy costs. Where we see as RESA the REV proceeding going is better quantifying the local value of that distribution network, so that if the utilities in their role as the DSP can project what the expected value it is by location, by network, maybe by feeder, customers and their service providers can plan for and integrate that value into, in addition to the existing average utility costs that are in the demand and energy charges, as well as the commodity costs from the New York ISO, to come up with a whole package of value so customers can be informed as to what the cost benefits are of changing their behavior or investing in equipment. This total value is key to generating more penetration, and I think addresses perhaps Commissioner Berman's question yesterday, that REV really can complement the existing capacity markets. Our view is that customers who can curtail load should be able to get the full value spectrum, and if it can be articulated and quantified, then customers can add capacity, energy, their T&D rates, and perhaps this local distribution value into the benefit side to invest in the most efficient measures possible. The other key to making it all happen is to get the settlement and the metering accurate so that customers who perhaps don't have hourly metering now, when they change their behavior, we can capture that change in an unambiguous way, reward the customers who are changing behavior, and not just at the DER level, but we need to flow that information all the way up to the ISO settlements, because there's currently a gap of trying to deliver these value-added products to smaller customers who are not hourly metered.
Okay, good morning. My name is Paul Herring with Central Hudson. I'm here this morning on behalf of the joint utilities. I think we all are anxious to see where REV heads, and we are truly supportive of the vision the Commission sees here, but I think the devil is in the details, and it's important to have these type of dialogues to better understand those issues. I'm going to touch on really three areas this morning that we see as kind of critical when it comes to system information and the system itself. One is that ultimately I think we all understand the need for ensuring the reliability of the grid, and that's first and foremost in our minds, to make sure that what we do here truly improves the efficiency of the grid and ensures that the grid is even more reliable than it is today. And vitally important with that will be, how we protect some of the information that's being provided is through the process. And when it comes to information sharing, there's really two areas I'll touch on. One is what I'll call market opportunities, and that's where the utilities can provide, or the DSP can provide, information about where these DERs can be most valuable to the system. And really the second is going to be, the back and forth two-way information on how these DERs are acting and performing. And I think that's going to be critically important so that we understand from standards and protocols how that information needs to be shared and how do we value those resources. So when it comes to the market needs or the market opportunities, I think there's really two kind of paradigms. One I'll call is more short-term, where the planning is being done at the DSP level, identifying locations on the system that could see a need from a resource or a investment, and a traditional T&D investment based on growth. And that could be at the transmission level, substation, distribution level. And I think it's good to understand that there's a dynamic mix of where those DERs could provide value. And again, I think one of the things that we need to understand, though, is that under the current economic environment, at least within our service territory, we see actually demand reduction and not demand growth. So that there's a lot of infrastructure needs in order to continue to ensure the reliability of the grid, that investments need to be made by the utilities. And really for the benefit of the DERs, because without the grid, the DERs cannot provide that value. I think there's also potentially a longer-term opportunity for the DERs. We can identify maybe longer-term needs, and we can talk a little bit more about how we provide price signals with regard to that. And then the second area is on the grid operations. And again, I think we've had some discussions this morning about having better awareness of these resources and being able to forecast and ensure we can measure these resources so that there is true efficiency. And we don't overcommit on a daily basis. And then ultimately that the bidirectional flow of information with these resources is kind of secure, so that information that's critical from a market perspective is maintained confidentially. Thank you.
Thank you. Good morning. My name is Lawrence Jones. I'm Vice President for Utility Innovations and Infrastructure Resilience at Alstom. Chair Zimmerman, thank you, and thanks to the Commission for the opportunity to offer a few remarks here regarding the REV. As an opener, I'll just make a quick statement regarding Alstom. We've been working and developing IT systems for electricity markets around the world for at least 20 years, working both with ISOs, RTOs, as well as DSOs. And one of the common lessons we've learned from doing this around the world is that developing markets is clearly an evolutionary and adaptive process. And I think that is something we need to bear in mind as REV evolves. That is evolutionary and will be adaptive, and we see that as very important. The other thing that we think is fundamentally important here is the issue of making sure that the stakeholder engagement process works from the beginning. And in this regards, we have to say that we're very pleased with what New York has done in terms of really active stakeholder engagement, and especially how you've gone to work in terms of how you've developed the straw man proposal. We think these measures are similar to what we've seen around the world, and it sets the basis for being successful going forward. In terms of information, 5 key points I'd like to make just to sum things up here. The first thing is that flexible and robust location information, we think, is fundamental to DSP. The issue of location cannot be underestimated. The other thing that's important is that the information that needs to be exchanged has to actually promote what we consider to be value-based service transactions. And I think Steve mentioned it, and we'll talk about it more on the panel, but I think that is extremely important. DSP could play the role of an information hub, and here we're not making any assumptions about which entity becomes a DSP, but just speaking generically based on what we've seen in Europe and in other parts of the world where a similar trend is evolving, is that the information hubs become an opportunity to really address some of the issues of non-discriminatory sharing of information. So putting in place such an entity with such a hub could help. Thirdly, that the information that is exchanged between the various actors has to be done on a common platform to make sure that the interoperability of the information as well as the functions is done in a way that really makes the market work as you intended to do. With regards to this issue of the grid as well as the markets, we believe that we need to leverage the experience from wholesale electricity markets, how they have evolved, lessons learned there, and see what we can apply to the DSP model as we see it evolving. And then the last comment I will make was one which addresses this issue that DSP will be part of what we consider to be a multi-tier architecture. Currently, we have our information flowing from the RTO to DSO down to the remaining actors in the system. With the DSP coming involved, we see them playing an intermediate role in terms of making sure the information is shared both upwards and downwards. So with that, I'll stop and look forward to your questions. Thank you.
Thank you. I want to start with a few questions. First, Kevin, on the idea of marginal distribution cost is obviously somewhat foreign to the way we think about it today. So could you, it would be helpful if you would elaborate on what you see as the components of those costs and what are we unpacking, I guess.
Thanks. It's tough to do this without a visual, but I think a visual does help. I mentioned earlier the quadrant approach, and that there are 2 components in terms of segments. One is the supply side, the other is the grid side, and then you have a fixed and variable cost, which a lot of the folks in the room are comfortable with and familiar with. But I think when you think about building a distributed marginal cost, you have to think about not just the assumption of reliability and then trying to hone in on much more discrete avoided cost from a consumer perspective, but assuming that there is almost an evolving impact on reliability dependent on the DER integration going on in the system. So as we build up these 4 quadrants, we see first on the supply side the ancillary services plant following in the LMP approach at a variable level, coupled with capacity premiums and the future value of embedded capacity or added capacity on the fixed side. On the grid side, however, it's a different conversation. On the grid side, you have things like deferred cost of added infrastructure, bank capacity deferral on the fixed side, and what typically goes in as components of an IRP or a capital budget that utilities may visit out of the distribution planning group once or twice a year, change their view in terms of which circuits or which substations get attention. But that's based on much more of a long-term planning approach. But coupled with that, as DERs start to penetrate a specific circuit or a specific load bank, you have to look at the impact on power factor, KVAR, and other reliability measures that are intraday or there could be sub-hourly. And those measures, coupled together, all 4 of them comprise a specific price. And the real question is, at what level of granularity is that price or that cost visible to the stakeholders? And you could argue with ubiquitous AMI, it could be deployed all the way down to the individual premise. You have econometric modeling that will take you there, but not necessarily grid reliability information that frequently at that level. So you may come to a point where you have a transformer level or a substation level DMC that allocates the value of each one of those attributes to that node. And people make decisions on how to allocate capital that way. What we see as the biggest potential failure to address this level of granularity is the misallocation of capital. And I think using average avoided cost has been great from a long-term planning perspective, but now there's enough data to be able to handle these conversations and these decisions at a more granular layer, whether it's transformer or premise-based.
Does anyone want to respond, comment? Because I'll have another follow-up. Go ahead.
Yeah, Audrey, I do think Stephen has I think the approach Integral Analytics is looking at is a very valid approach in terms of how this is quantified. I think the issue becomes one of how quickly does the market mature till we get to that point? And I think that's one of the issues that I think that we want to kind of create the vision of where things head, but maybe we need to kind of create that runway approach of how do we get from point A to point B. And I think one of the things that we're doing currently, and Con Ed's doing it, and NYSEG's doing it, and some other utilities, are trying to create these more discrete kind of marginal prices for T&D deferral, so that we can create the value stream and then start to kind of monetize some of these value streams. But some of the other ancillary services may not mature for a period of time until you have sufficient penetration of the resources.
And I think if I could follow up on Paul's statement, I think it's exactly right. The ability to be informed in terms of what the deferred cost is on a per kW or per megawatt basis behind a certain segment of the circuit really depends on the utility's visibility to the attributes of the DERs available to serve that role. So I think it's definitely a bi-directional information flow. It's not just the utilities publishing some genericized or washed reliability component to this equation. I think it's DER vendors providing attributes, whether it's capacity or dispatch, discharge attributes, and providing that impact or expected impact on load profile back up to the utilities so they can make those decisions.
And my follow-up question, then anyone can respond to it, because it seems to me, coming off the last panel, one of the things we talked about was the barrier, that standby rates can be a barrier to entry, and somewhat of a recognition that if we have enough distributed energy resources on the grid, you could end up having an opportunity where the standby costs go down because you have this intrazonal pricing and the ability of various resources to back up everyone else. Well, does it present a chicken and egg problem in the sense that until we could start pricing out the value of multiple distributed resources on the grid, we may be overpricing the value of the system and disincenting investment. So would it be of value, even in the absence of the resources, to start modeling out what would be the potential in terms of avoided costs and value to the network based on how many distributed energy resources we can have? And is that something we could, is that the answer of how we set these rates moving forward? That's a question to everyone to try to figure ourselves out of this box.
So as a service provider working with customers to develop operating strategies and investment strategies, understanding the expected value is key. So what RESA would hope that, we expect each utility will have different valuations because their systems are different, but have a common platform of communicating that value out. So in some cases, the marginal value of that local element may be zero or something real small, but as long as that's communicated out, we can then start making informed decisions. I think you heard a little debate on the previous panel that there's probably kind of like an upfront sort of commitment type of approach where they might do, the DSP might do a solicitation, who can provide this type of resources with some programmatic requirements to make sure that there's a firmness so that the utility knows what they really have in the quiver when they need it. And then there's probably a real-time element of covering the variable cost when you do deploy it. You need to make sure that customers don't get fatigue and lose their interest in participating. So I think there's a trade-off of, is it a capacity versus an energy type of compensation? Is it a forward contract versus a spot market? My sense, without prejudging the outcome, is that the utilities are going to need at least seasonal, if not longer-term commitments to avoid investments. So you really need more of a sort of contractual, I sign up for this program and I understand the requirements, and for at least this planning year or perhaps multiple planning years, the customer understands their obligations.
And I'd agree with what Steve is saying, that that commitment is going to be critical in terms of ensuring reliability. But I do think there's a way to address, individual, DG or DER resource inability to perform by potentially the provider. In our case, we are looking to have a third-party provider provide these services, become an aggregator. And to the extent the aggregator may need to oversubscribe to create some margin, it's no different than how the markets run today, with effectively reserve margins that exist at the wholesale level, or in terms of ensuring grid reliability. So my sense is that those barriers could be overcome with regard to standby rates by potentially the way that the products are structured.
Yeah, and if I could jump on this back, both the previous discussion and the one we're having now, relative to kind of the plumbing and the decision making. What I'm hearing is there's a lot of disparate data feeds that are going to come up into the DSP. And it feels a lot to me like, I'll kind of get on this side of it for a minute, that the incumbent utilities probably maybe want to be that in the beginning, because this DSP application, for lack of a better way to frame it, can kind of sit on top of their data analytics, right, and can perform that function, because they'll have that localized information, and the smarter that granular data gets, as we've heard a bunch of times here, the better decisions will be made in a more timely fashion. So I think they're kind of uniquely positioned to kind of get that going out of the box.
Just make a comment. So I think as we talk about, the word value keeps coming up in this discussion. I think is very important. But I think we shouldn't forget the first point I made regarding the locational model, this locational notion of what we're doing here. Because you can sort of have a value defined today, but the dynamics of how the grid functions over time might change. Right? So the locational notion of these devices as they appear in the grid will, to some extent, have an impact on the actual value you generate, right? So you can put a device in today, network conditions can change, you could have congestions in the system. All of these things affect the long-term value. So we shouldn't underestimate how important understanding the locational nature of what we're doing. That's something we have to keep paying attention to.
Yeah, and I would be in violent agreement with that from the perspective of, as those endpoints develop, whether they be generation or parts of the distribution network, they need to be intelligent, because in order to get to your point of, we need to know how valuable or less valuable they are, that information has to flow freely, and it has to be somewhat real time, because if it's a month old or if it's 6 months old, then it becomes problematic over time.
And I'd agree, and I think, with the demonstration projects that we're currently underway with, we've identified, 4 discrete areas on the system, and ultimately, by a circuit level, identified where we see value. I think one of the things that we need to think about is the information that's provided as to, we provide how many customers in the pocket, how many megawatts, the time frame needed. Do you provide information relative to what the T&D cost would have been for the traditional investment? Or do you basically allow third parties to come back with their best offer, not trying to undershoot what the T&D deferral price was in terms of having that as a proxy? And I think those are kind of things that we need to think about, as maybe as it matures, maybe less information is necessary in terms of the price signal, and depending on how the market gets to be structured.
The theory I'm working under, and I just be interested, is that as we, just like in any other network, you assume that the cost benefit's not stagnant, and as you would add additional resources, that's going to change the value of each incrementally plus historically. And the question is that if we price the cost of adding a resource too high, or price the value too low, you're going to end up over or under procuring. So the issue is somehow coming up with some way of modeling out not just where things are today, but what's the potential economic value, and then having a mechanism to adjust as if you guess wrong. That's what I'm assuming, but I'd be interested in what you're thinking.
And clearly, as we dispatch more of these DER resources, we will change the system topography, and there, one would expect that the cost allocations would then change as a result of the power flows changing. To some extent, we've made a policy decision in the state to perhaps underprice the cost of, behind-the-meter renewables based on our net metering tariffs, where, there's a social goal of increasing participation, and, perhaps that's been underpriced, but we're consciously doing it. And so as we get more and more local pockets of renewable generation and other resources dispatching, you could very well come back and rethink how we're allocating costs.
So is that would suggest, as time goes, we would expect the fixed components of the grid, the network, to go down and the variable to increase, all the other things being equal?
I'll defer to the rate engineering side, but
Yeah.
it definitely will change the outcome. I'm not sure which way.
Okay.
You probably have better insight than I do.
I think it would actually help optimize that. So I think one of the formulating questions, or the foundational questions, is this a deterministic model or is it a reactionary model? And the deterministic model would say, start with load planning in a traditional sense, but recognizing that over the course of time, you're going to have to throw multiple forward curves out associated with penetration of different DER at different points on the circuit. And in running those load models and determining where the band is, where the band resides, and ultimately all these different components will settle out as to their individual value. So it's kind of riding the horse out of the barn instead of running after the horse after it's leaving the barn, as we've seen in other jurisdictions where in a lot of cases distribution planning takes a back seat and they start seeing penetration rates and things like that on certain circuits impacting transformers and having unintended consequences with respect to retroactive requirements on CapEx.
Yeah, and I agree. And I think one of the things that we are learning from some of the wholesale markets, especially with ICAP prices, is not having price certainty and tends to result in underinvestment. So I do think that while there will be variability, I think at least initially maybe there has to be some level of certainty of what those prices are for some fixed period of time. Because if we create truly a dynamic market, we may see similar results as to what we're seeing on the wholesale with regard to lack of new investment on generation, or the financial markets not being able to support that.
Yeah, and also I think when we think about load forecasting, going back to intelligence at the endpoints, the technology is really here today to say, okay, because I know what's flowing into that customer, I don't only know that it's energy, but I also know what's the load on the other side of that. So it gives the utility the ability to say, okay, based on the fact that I know this guy's going to come home and plug in his Tesla at 6 o'clock every night, that's going to make me make different decisions, and maybe it's not there at certain times. It's kind of a simplified approach, but ultimately being able to disaggregate those loads and plug that into a model that allows you to more accurately forecast, helps to solve some of these problems around the table today.
I have another question. It's just sort of follow-up. So one is, I'm thinking that, based on the conversations of the last panel and what we've heard, is that to the extent, and it is our objective to create liquid markets, one of the things that's going to be important is that the type of information that you can get in New York City is similar to the information as it appears in Central Hudson as NYSEG, because otherwise, if they're different products, different information, then it's going to be hard for the markets to form. So with that does sort of presume some level of uniformity. And then in terms of that uniformity then, and to, as you heard in the previous discussion, maybe a desire to ensure that even if the DSPs are separately owned by the distribution utilities to the market, they look like one entity. Does that imply with it that when we take a look at the platform and the architecture, that we should be thinking about that the systems that the distribution utilities start deploying to interface on that two-way market need to be the same system? And if not, if we end up deciding at some point that we want to go from separate DSPs to a unified entity, is that going to create a problem? And having been through trying to interface Alstom and Siemens systems in the past, it's a scary thought to, if you have 5 different systems and trying to make them look at one, but I'd be interested in your thoughts on that.
I think, Chairman Zima, I think one way to look at that is the issue of standards and making sure you have, I think at a system level, one of the challenges we've seen working with systems all over the world is that when you start bringing different modules into the system, you want to make sure that the modules are interoperable. And so one way I think you can mitigate some of the concerns you have is to perhaps already now start looking at what would be the communications protocol for the different applications within the systems, so that when you do bring the system together, you actually have less issues, a lower amount of issues because of this interoperability. So for example, you could have a module in, say, Central Hudson system that could equally be used in Steve's system in Con Ed, right? But having this sort of interoperability at the component level helps to deal with the integration at the system level. So when you do aggregate these systems, then you see some of the challenges you've had with these larger systems will go away.
Yeah, you could start, sure.
I think we need to differentiate between the system information to reach out to customers and make informed decisions versus the information needed to dispatch and keep the DSP aware of what the system configuration is. In terms of the information needed to understand what zones are important, what networks are important, what feeders are important, RESA had suggested we get sort of a stakeholder group to identify those data elements so that they're common across the state. That way, a customer with facilities throughout the state could have an informed way of saying, does it make sense to install controls, aggressive building management system in all of my facilities based on sort of a common set of inputs. That achieves efficiency of deployment. One possible model is to extend upon the existing information that's available to retail ESCOs in an EDI format with customer consent that provides a lot of granular data, including on a per customer basis what capacity zone they're in, which is very important for pricing commodity. If we could add extra elements, it would help us and the customer, because sometimes it's not intuitive to the customer, identify what network zone they're in for purposes of, what the DSPs identified as valued areas. That would help make informed choices. A separate issue is then how does the DSP dispatch those resources, whether it's through email blasts, RF communication to, for example, central air conditioning cycling programs that, my local utility has in my house and has owned that for several years without any market power concerns. There are different ways of deploying it. Clearly, there should be a two-way communication, though, when the DER provider knows that there are outages, and outages will happen. It's physical equipment that we control. We should be communicating it up just as we communicate to the New York ISO when we're participating in special case resources programs to make sure that the control center is as aware of what their resource mix is.
Yeah, I would also agree that standards play a huge part in this relative to kind of the feeds that need to go into the DSP platform. There should be a baseline on that. Some may do better than others, but I would suggest that, as that framework evolves, that they be not only robust, but, very aggressive relative to the amount of data that comes not only from the DERs, but from the grid, from the edge of the network, and from the overall grid automation perspective as well. So, violent agreement on that, that's going to help that system work, just much better, and also be maybe more transportable over time.
And I agree, standardization is going to be important, but I do think that each utility could deploy, or DSP could deploy its own ADMS system, and ultimately, if it's decided in the future that there becomes a statewide entity that becomes a DSP, that those systems could be integrated. I don't see that as a huge hurdle. I think when you look at the full deployment of what we're trying to do, while software is obviously systems are a critical component, I don't think they're the largest cost component of everything we're trying to do. So not to say we would have to throw things out, but I do think that as long as we have standards, we'll be able to integrate those longer term. I think the other piece of it is, with controlling these DER resources, the involvement of DERMS systems and will be important, and understanding that those systems are kind of using an open protocol in terms of communication will be critically important. So again, that's going to tie back to the standards.
Thank you. Questions? Yeah.
Let them start this time.
Yeah. So I just I just wrote down some things here, because again, I don't mean to beat a dead horse, as Stuart Nackme has said, but ironically, that term I think actually came from when in Parliament, when they were not willing to institute certain reforms, and folks felt that it was time for a revolution or an evolution, and that they felt there was going to be beating a dead horse. So just so you know, I think it is sort of ironic. I'm a phrase lover, so but I really think it does come back to the customer data issue, and I really think that for me, it is all about the data, and there's varying degrees of that data, but it's also about who's going to get access to what, when, how, and how are we going to do this, and what are the standards and protocols that are necessary, and do they change depending on the customer, or do they change depending on the type of information, or who has and controls the data. And so, part of the issue, I think the elephant in the room is at what cost? And, to save money, do we need to spend money? And is that something we need to factor in and also understand that reality? So I do think it does come back to panel 3 and also the some of the financial and cost-benefit analysis that needs to be done. And I don't know if people are focused on that when they talk about this, and if you have any thoughts on this.
I think from our perspective, it's a multivariate equation as we look at it from a quant perspective. But I think part of it, the answer is, where do you expect the DSP transactional layer to occur? Does it occur at the premise level every single time, such that load profile for individual customers needs to be transparent upstream? Our argument would be no. We would say that at this point, that you can heat map an entire service territory and understand, based on both grid and supply variables, where the most appropriate places to put the first DERs and what type of DERs, based on their published attributes, should go there. And then any kind of incentive dollars and based on avoided cost based on that transactional price should follow. So in that sense, protection of customer data is preserved because you're doing it at a block level, whether that block represents the transformer or a higher level of interaction. And at the same time, you're preserving the sanctity and the security of the grid information itself as to what's driving the attributes they want to preserve, kVAR, power factor, those kind of things, voltage support, and those meet at a certain point. We're just not certain if that's at the substation, at the transformer, or where it ends up being, but we think the data is available in different pockets, and it's about determining, honestly, utility by utility, how sophisticated their systems are to support that.
So as I mentioned before, currently ESCOs provide more than half of the commodity to customers in New York State. Our expectation that many of those same ESCOs are going to be, actually already are, or are planning on becoming DER providers. And so it would be an inherent conflict to have a different set of rules to access some customer data for commodity pricing and a different set of rules for accessing arguably a lot of that same data for DER supply. So it makes intuitive sense to find some commonality, and based on the short-term or the near-term objectives of trying to get some of the REV aspects implemented, to look to leverage the existing systems, which are EDI protocols for communicating that information out to ESCOs, to see what additional data elements are appropriate to add to that data string and use that as an initial vehicle to get the information out. The existing UBP, Uniform Business Procedures, specify certain safeguards to protect customer privacy. I think there's a separate issue of how does the utility, in their role as DSP, communicate their granular needs. That is probably more of a public information, both to increase customer awareness of, hey, help us defer this capital investment, and that can be done without revealing individual customer names to the public, but you just identify a region where there's interest. In terms of the who pays, I'll go back to the ESCO approach, where there's a standard set of data that's available to customers, consultants, and ESCO suppliers, basically free of charge. That's sort of the generic basic to get started. If we want to then poll interval data, to get more granular data, we actually pay the utility depending on how often we poll it. So for the more perhaps transactionally costly data, there is a mechanism out there to say, if you want more frequent information, and information is very key for a lot of people to dispatch, people should pay an appropriate cost for that.
And I'd agree with what has been said previously. I think, currently the ESCOs have access to quite a bit of customer data, granular data. It may not be granular on an hourly basis to all customers, but I think you have to look at where's the load distributed on the system? And, you know, at least within our service territory, 10% of the customers represent 50% of the load. So when you look at 300,000 customers, 30,000 customers represent 50%. So you need to go to every endpoint of the system and have granular data to provide those signals, market signals. And the argument is, I think, is what Tony and Kim were saying, is that there's ability to aggregate that information at the bus level, at the circuit level, at transformer level, to provide the signals. And then that information, the granular information, can be provided to you know, the DER providers that are working with those customers, as long as they follow uniform business practices. And again, to the extent there's more information that's needed, that could be done as a fee for those specific requests.
Just want to make a comment. So, you know, and the way we see it is, as we talk about DER providers, we sort of need to step back and maybe categorize them, because different DERs will require different sets of information. And I think the concern here is sometimes for folks we've spoken to both here and in Europe is that it's just when you talk about customer data, which is a very broad category, right? So for a DSO, a customer could be a large CHP plant, right? Well, that CHP plant may have a whole different set of data requirements to run their business or to interact with the DSP in this case. So I think we need to really look at the services that will be provided by the DERs, if you may, and let the services to some extent drive the information requirements. Because I think to some extent oftentimes we're seeing people make assumptions about what information will be needed without even looking at what services will be provided. And if you start to look at the services you want to provide, that may help to sort of address some of the concerns you have. Because if I'm a large CHP plant, for example, I'm a DR, I'm playing in the market, I have a whole different set of data requirements as opposed to if I'm an aggregator touching residential customers, right? And I think what sometimes confuses this discussion is we just say, well, customer data. Well, oftentimes we forget that customer there's a huge spectrum of people who are considered customers. So my suggestion, Chair Zibelman, is that I think, as I said, markets evolve and they're adaptive, and I think to get things running here immediately is sort of let's look at those customer segments that have least controversy in terms of getting the REV up and running, and then over time you can address some of the ones that are most specific to address your concern.
Yeah, so again, to just jump on top of that a little bit relative to, kind of the endpoints. CHP does not equal rooftop solar, does not equal somebody's thermostat. However, it's still valuable that they're all intelligent and can communicate. So that's going to provide all of the things that, you gentlemen had spoke to, relative to, the disparity in those resources. So still kind of think that, in violent agreement with what we just said here, but ultimately we can't lose sight of the fact that they're all equal, but some are more equal than others relative to their effect on the network.
In the choice between additional distribution plant and substations on the one hand versus DER on the other hand, should there be a price recognition of social policy concerns like clean energy, so that, for example, solar and DR and energy efficiency might get a plus, and reciprocating engines and microturbines might get a minus? Or is that a level of complexity that we really don't want to open at this stage of the evolution of the markets?
We try to do that through REG and through other emission costs that are in the commodity charge. Do we do a good job of that? Probably not, because REG is only targeting the utility aspect. It is not valuing the carbon of other local sources. For example, if you're a smaller generator under 20 megawatts, you're not required to buy REG credits. So there are imperfections in the current model that we could probably improve upon or recognize those gaps and look to adjust for.
Greg, I think it's important that as we establish the market, we send the proper market signals. And I think one of the things that we are concerned about is that we try to monetize externalities to the extent that they are not monetizable. And I think those are areas where we definitely need to have dialogue, because at the end of the day, I think we all want to see this succeed. We think there's value here, but creating the value stream is going to be critically important in terms of how we send those price signals, and are they truly market-driven, or are they being artificially propped up based on strictly policy decisions?
I would agree with what Paul's saying. I think it's difficult to quantify, and I think as an analytics company, we'd say, sure, just add any other variable to the algorithm, and we'll knock it out. But I think I'd argue that up to this point, the subsidization, capital subsidy associated with renewables has provided a significant social policy move toward the deployment of these DERs. And I think once that starts to step back, then you're going to start to see really what needs to be added to the formula to determine whether you differentiate based on type of asset or whether the cost parity has been achieved, and you just base it on what you typically look to in terms of dispatching nodal energy, regardless of type.
More data means more available data. So I just wanted to, is there anything we as regulators should be thinking about in terms of cybersecurity? With the, right now, we can closely watch the utilities because there's 5 or 6 of them that we need to monitor and make sure that they're up to speed. But availability of data to all sorts of providers increases the risk. What should we be thinking about in terms of requirements to protect the information?
I don't think we're necessarily advocating publishing otherwise sensitive data up into a new repository.
But if it's out there, if it's being transferred, it's accessible.
If it's being transferred, maybe the transactional signal is being housed where the data source is actually resident. So if in case of KVAR or power factor or specific grid information, that's published up, it's washed through a metric, which we would propose would be the ultimate clearing metric anyhow. And so you're not pushing data into what you'd say non-traditional sources or non-traditional repositories, so that access, there'd be another attack surface, essentially, for that data. So we would say that the transaction component and the publication of that metric can be centrally located with the DSP, but not necessarily pulling all of the source data up into that level, if that makes sense. Because then you're talking about things like publishing behind-the-meter information about assets riding on protocols like Modbus and things that have proven to be not so secure over time. So you want to mitigate that at the node and continue to make it more of a metrics-based transaction, in our view.
Yeah, and I would get on that too, that the DSP will be omniscient relative to what's going on underneath it. However, what it sends out, should be very well defined and also very secure in the manner that it's transferred. So, I would agree that, yeah, it's a big data problem, but there's only a piece of that that's going to, get out to serve the market.
How do we make sure it's very secure? I mean, who's in charge there in terms of the information flow?
So Gary, I think from the standpoint of as a DSP and operating the system, we have that experience today with regard to how we operate the transmission system and NERC standards. And again, not to say we're going to build everything around SIP requirements for the distribution system, but I think we will leverage the experience, the standards, the protocols from an operating information standpoint to control the data flow. And our experience has been that, again, that would best be in secured networks in terms of having that information flow. When it comes to the customer information, I think that becomes a little bit more troubling, right? I think we have to understand at what level that access to customer information is going to be provided. We understood, Mike Mager made a good point about, some of that could be considered, somewhat confidential and proprietary in terms of, competitive nature. So I do think we need to make sure that the rules of how that information is shared, who has access to the information, is controlled, and everybody plays by the right rules. So again, I think, not to say we have all the answers, but I do think, at least from a grid perspective, there are rules that are already being followed that can provide a roadmap for how we best control at least operational data.
Just, excuse me, add a comment there. So one of the things we've seen, and I mentioned this in my remark, is that already in Scandinavia, for example, they're creating a lot of sort of information hubs to support similar things we're trying to do in New York, albeit some of what they're doing now, their hub is mainly to allow switching between customers from different suppliers. But I think there are lessons that can be learned from how they've gone about doing those hubs in Scandinavia, where initially they had probably 10% of the load that were, or the customers that were sort of connected and exchanging information via the hub. The last I checked, both in Norway and Sweden, they've come up to be 90% of the customers are now connected via the hubs to allow information to go from the customers to the suppliers, and they can switch. So I think there are lessons that we can learn from them, and in terms of what we might do here. I would also mention that, you mentioned standards here, Paul, but also if you look at the work being done by, entities like NIST and the Smart Grid activities at Gridwise Alliance, I think there are a lot of discussions about how you protect information. So I understand the concern, but I think we've learned enough today that I think we can protect the systems to the level that will bring satisfaction to the Commission.
To be facetious, that's what Target thought, but...
Yeah.
Yeah, but you see, that's the beauty, because now we can learn from Target, right?
How do you relay that to customers so that they do have a comfort factor? I mean, so many people are very interested in the modern technologies and getting involved, but the fear, again, is like a Target. How do we relate that, and how do the DSPs and other providers deal with customers and let them know what is available and what safeguards there are?
If I just share a little bit from the Scandinavian experience, because we're deeply involved in some of the work they did, there was an early engagement with customers trying to explain, first of all, breaking down what cybersecurity meant, going into details, and giving them the sense of comfort that we're not taking all of your information and sort of just giving it to the utilities or giving it to the ESCOs. I think that level of education of customers is one reason why they were very successful. If you imagine, it took them less than 5 years to go from 10% to almost 90% of the population of Norway connected via this sort of this information hub. So I think the issue of educating customers is very important, but then also being very, I think, transparent in terms of letting people know that sharing information is not being done with some sort of a divisive intent. Instead, let them know why the information is being shared, right? So if you're giving information to an ESCO, for example, let them know why the information is being shared, as opposed to say, well, we're going to, get all your data and give it to the utilities. The last comment I'll make there is one of the reasons why we as an industry, suffered some initial backlash with regards to smart grid was because everybody's focused so much on sort of a customer data, and you scare the customer from the start, right? So I think the approach would be let them realize that this is something good and give them the safeguards at the start.
Yeah, and I'll go back to that too, relative to the security of the grid and machine-to-machine networks, which tend to be inherently a lot more secure than what you might see at a Target database sitting in a data center somewhere. It's very difficult to intrude on these networks. They're designed for to be impervious for things like man-in-the-middle attacks and kind of outsiders getting in. But if they do get in, what can they do? Usually nothing. We could spend an entire day on the security of that piece, and we'd be happy to. We spend a lot of time talking about that with our customers. But that part of the industry spends a lot of time trying to break itself. We have networks deployed where our customers spend a lot of time understanding, okay, let's do a hackathon, let's do some penetration tests, let's figure out if we're secure or not. So just kind of bolster what's been said so far, for these kinds of networks, a lot of folks think about the security of them, how to make them better, and since they're based on open standards, you have a lot of brains trying to fix the problem once holes are defined.
Can I'm going to just take us back a little bit because our focus, is on this panel. Is around system data, and it's in terms of what kind of information do we have to make available on the system for potential vendors to want to invest. And one of the questions I have is from a rate perspective. One is, can we get some agreement if we're thinking that we're starting at the starting gate of trying to attract investment in? I think, Steve, you started to say it. What kind of information is going to be the most useful so that in setting standards, we could start looking at what utilities ought to be required to provide in order to make certain that the markets at least can develop a pace. Secondarily, I have a rate question for you guys, which is, traditionally the way we regulate is that if there's a cost to providing this information, it gets socialized across all customers. Should we begin to start thinking about that the value of the systems that need to be put into place in order to provide this information should not necessarily be charged to all customers, but that there should be at least some thought through a rate design that the cost of these additional systems ought to be borne more by those who are going to take advantage of them. In other words, the market participants. And then the third question, which is that the assumption we're thinking is it's the DSP that's providing this value. If there's some raw information and then there's additional value around aggregating or analytic information, should we allow that to be a competitive process, which maybe the DSP could provide, but maybe we should allow third parties to come in and allow that data and allow them to charge for that information. So if there's analytics, if somebody wants to do a model of a distribution system and say, boy, going forward, you really ought to be thinking about putting some resources over there and charge for that. Is that something that you could conceive as a new business model, either for a DSP on a purely non-regulated basis or for third parties, or? So I'll let you tackle all three.
I'll take the third one first, if that's okay, primarily because I don't remember the first one. But I can only process. I'm a serial processor. No, yeah, exactly. That's a long story. In terms of analytics, I really have a hard time divorcing the analytics associated with specific circuit valuation and nodal valuation on a circuit from the utility's core function of delivering reliable service. And as much as I'd like to say, sure, analytics companies should be able to run in and provide any kind of modeling that they'd like, that really starts peeling apart the concept of what we're providing as a DMC and gluing together grid and supply, variable and fixed costs, such that in Paul's world, we couldn't come and say, hey, we prescribed that you should have this many solar storage combination components on this feeder and here and there, when we don't have access, unless he provides it to us, his power flow modeling tool. And that's what we've endeavored to do, is merge power flow modeling and econometric modeling so that the utility, and ultimately utility serving as DSP, is making a holistic decision on that valuation. So I would say at this point it's tough to see independent analytics coming in and prescribing a DER methodology across a distribution system. You have to start with the distribution team as a partner in that regard, but ultimately it should evolve into the point where the distribution planners and DSPs are publishing a heat map and saying, we don't have to have individual customer data, but aggregated at a certain level. Here's the heat map. And to Paul's point again, the 90-10 situation where so much of what could be mitigated on deferred cost could happen within a very small territorial area. And once you've mitigated that, then you start determining the valuation of those shoulder periods, those shoulder areas in that way. So I kind of merged a couple answers. Hope that helps.
So I'll take the first question then, because I do remember that one.
Thanks.
But I'm glad Kevin answered the third one, because I wasn't sure I was focused so much on the first, I wasn't digesting the third.
Well, there's the first and the second. First is what do you need, and second is should you pay for it.
Yes,
right.
Yes. So what you need, as Risa said, we think that we ought to get a working group together to make sure we don't miss something, because we don't want to roll something out and then day two say, oops, if we had just added this piece of data, we'd be all set. But and I think some of it, and I'm going to push back to Paul and the utilities, some of it has to start from them as to how granular are their needs expected to be, because that's how we ought to approach it. And if they really want to get down to feeder-level solutions, then we need a way to communicate feeder-level locations of customers. If it's more of a network or a region, then we can have bigger circles or bigger chunks of data. I think the key, back to your question about cybersecurity, as long as the utility is not communicating to us where is that transformer, and they're just saying, we have a potential transformer overload in 3 years, and here are the customers that are impacting it, I think that level of information is reasonable to provide to the market, and as I was saying, appending to existing sources of information so the customer can readily know, hey, if I change my behavior, I'm adding value to the utility and helping drive down long-term costs. And third-party vendors can also take advantage of that. The who pays, while there's always this balance of, let's get the users of the data to pay for it, I'd go back to, we're embarking on this whole new vision because we want everybody to have lower capital costs or a better system utilization of the entire utility grid. So even if the non-participating customers, they will get a benefit through a successful deployment of DER resources, because we'll be able to avoid the billion-dollar substation in Brooklyn, Queens. We'll be able to have more efficient utilization of our grid. If, as Central Hudson has said, we tilt our solar panels a little bit to the west, we get some coincident usage that if you're just maximizing it for total megawatt-hour production and facing dead south, you're not getting. So, a little bit of incremental improvement has societal value, which is why I think the core base should be paid for by all customers, because if you put it into a user pays type charge, you might deter participation in it. Although I will agree that there's probably going to be a lot of real detailed requests. Can I have the data sliced 30 ways till Sunday and granular down to the 5-minute level? Perhaps that should be a bucket of stuff that the utility should charge for, because it's not needed for the core rollout of DER.
So I think I agree with everything that's been said so far. With regard to the standardization for information, I think that's the joint utilities agree and even support doing deeper dives with stakeholder groups to figure out what's information is necessary. But we're not standing still waiting, right? Their utilities actually are embarking on proposals. Con Ed has the Brooklyn Queens project. We have a targeted demand management program for 4 areas of our system. NYSEG's looking at a program as well. So I think through the demonstration projects we'll gain some experience as to exactly how much information is necessary and what level of information is necessary, and it could vary. I mean, we have one region that covers 50,000 customers, and ultimately, another region that has only 2,000 customers on it. So do you even need to have different stratifications of information based on the size of the geographic region that you're trying to address in terms of the T&D deferral? And we may have to kind of learn by just going through the motions and seeing how this works out. With regard to the cost of the systems, I think we agree. I think these are what we consider foundational elements for REV, and that all customers should pay. I think one of the things which is interesting, and we have something proposed in front of the Commission, what we're finding is that some of these foundational elements can pay for themselves. There's actually grid efficiency that can be gained without even customer engagement through volt-var optimization and other efficiencies that we can deliver without even the customer being aware of that. And those benefits can be realized, again, and ultimately pay for some of these foundational elements. So, again, if there are costs, I think they should be borne by all, but I think we may be surprised to see that some of these new functionalities may actually provide net benefits. And then when it comes to the additional information that's provided, again, I think so long as it's consistent and standardized, that information should be available to all customers. To the extent there's specific requirements, again, I think there's going to be a need for some way to figure out what's the value stream and who monetizes that, and where does that value flow. Does it flow back to all customers? Does it flow back to the utility, the DSP? I think there's definitely more dialogue to happen around that.
Comment. So, in addition to that, I think I would say we should also bear in mind that the physics of the grid has to work. So we also need to think about that not all the grid-related information may be easily, or maybe it may be a good idea to give it all out from a physical security standpoint, right? And so the issue becomes then, how do you decide or define the category of information that Paul is going to give to the market, especially if some of those information turn out to be sensitive from a physical security standpoint, right? And so I think that is a classification that needs to be addressed early on, so that Paul and others don't feel they have to sort of give all the information. But I think from a reliability standpoint, from a physical security standpoint, I know, Gary, you talked about cybersecurity, but I think from a physical security standpoint, we need to clearly define what categories of information will be given to the market, and it's necessary for the market to have. Because from a physical security standpoint, maybe an aggregator doesn't need X, Y, Z information as opposed to him needing maybe ABC, right? So that classification, I think, is very important. We saw it happen in Australia and New Zealand, where they've been dealing with the same issue, where they've said, look, from a feeder perspective, we can't give certain feeder information out simply because for physical security reasons, right? So that is something I think the Commission needs to take into consideration as well.
Yeah, I wanted to follow up on that one. I know we've had instances, for example, when a utility told us they're doing maintenance on a transmission line over a certain period, that's frankly leaving themselves a little vulnerable. They may not have as many contingencies available to them as they had before. And that isn't the sort of information that you necessarily want to share widely, even if it might be useful in the short term to a demand response provider because they might be able to do something. How do we deal with that balance? We want to provide the information to the community so that they can do good things, but at the same time protect the system.
I think from a voltage support or capacity perspective, on a month ahead, week ahead, day ahead perspective, I think that allows excuse me, the utility to populate that part of the distributed marginal cost or distributed marginal price in impacting that. So as those things roll on, if you have an outage or if you have a maintenance issue that's going to take down capacity or limit or create a congestion point where nodal value is increasing over time, you publish that. You don't have to say why. You just have to say that it is happening and that is relevant in terms of this type of value for us in alleviating the congestion on that feeder or that substation. So I think that's ultimately, it's kind of almost, I want to dumb it down to the point of Apple Pay, but you're almost tokening the message up to the DSP and saying, we need this here. We're not going to tell you why. We're not going to give you the card number that sits behind it. We're going to say what we need. We're going to say how much of it we need and when we need it, and then the transaction can occur and it filters back and informs the distribution planners in that regard.
Is there a fear then that the DSP might use that for their, going back to the first panel, for their own, to favor their own facilities, for example, than an independent facility if they make more money that way? I mean, the whole, so you just said they can keep it to themselves, but they could also take advantage of that fact.
I think it determines on which side of the wall the owner of the DER sits. Yeah. And if they can't be sitting down the hall from the distribution planner necessarily, there has to be a code of conduct and a structure that way.
I would expect that that's one thing that Commission staff would work with and be aware of. And to your point, the operational deployment, as Kevin was saying, you don't need to communicate to the people you're dispatching why you're dispatching them. Right. You can give them a heads up, hey, tomorrow we may be deploying you, increase your awareness. It's like, great, I was expecting this, I don't need to know why. And as long as everybody in a network, whatever it's designed, or in a feeder location, is being equally deployed and given equal opportunity to react to that price signal, either if there's compensation due to the variable nature of it, or if there's an obligation, you want it, because it can work both ways. Sometimes this is not always found money to be deployed. If you're paying somebody a capacity payment, many customers would hope, perhaps cross their fingers, that they aren't called on too many times and it's a mild summer, but that contractually they know they have to react when called upon. So as long as everybody's being dispatched comparably and you're looking at performance results after the fact, I think you can have a reasonable set of safeguards in place.
So I'm not going to leave this point. I want to follow up though, Steve, to your question about your comment about who pays, because I do think that we need to start thinking about this a little bit differently. I mean, clearly the model we use in this industry is cost causation, beneficiary pays. But I think to say that if somebody is actually providing a service back to the grid, and therefore they're getting an economic value as a provider, and while that provision, if we do cost-benefit right, is going to benefit everybody because we're hopefully procuring in a smarter way, it does strike me that we need to start thinking about the fact that there are sort of two transactions going on. One's a sell and one's a buy, and that we need to think about thinking of separating it out, because if you don't do that, my concern is that you end up creating, in effect, another cross-subsidy, because the people who are getting the value of being able to provide the service are paying for it for the same, and they're still getting the benefit of the lower price. I would think that that just like if we're saying that the DSP is a platform, just like people who advertise on Google pay for the ability to get on Google, it strikes me that we need to start thinking about aggregators as customers of the DSP, in addition to the end-use customer. Be sort of...
I think there are some transactions where it would be appropriate to charge that out, whether it's extra information or whether it's the utility providing a service that really has costs. You know, what I think of is, in the past, some utilities basically provided an aggregation mechanism to allow customers to participate in special case resources programs, similar to the way competitive ESCOs like RESA members would. Well, we argued that the compensation to those customers participating in those aggregations should be market-based, that it should reflect an offset of the utility's actual costs. Otherwise, that becomes sort of a subsidized competitor to the RESA members. So there are, you know, I think that's a good example of the utility should factor in its cost in the value proposition. There it's really a buy of the service. They're paying the ISO clearing price less perhaps their administrative fee. I want to say it was 10% in some of the tariffs. Don't quote me on that, but that sticks out in my mind, to cover their administrative cost of providing that function.
And Audrey, I think, you know, Steve makes a good point in terms of there may be certain elements of information where, or capabilities of the systems that maybe a certain subset of customers should pay for. I think the one thing, though, that, you know, we just don't want to lose sight of is that the grid, and really that's really where all the investment is, right, is in the infrastructure. And that infrastructure is necessary and needed in order for these DER providers to provide the value. And that's where we just want to make sure there's no cross-subsidization, that those DER providers truly are providing a benefit, but they're also relying on the grid and utilizing the grid, so they need to pay for what their access point to basically provide that value.
Would the panel agree that if we're going to go down this road, we should establish collaborative working groups to define the necessary data and the methods of data interchange?
Yes. Greg, I'd say the only thing I would say that I agree, but I do think that some work is underway, and don't wait for those stakeholder meetings to start. Let's see how these demonstration projects work and learn from them, and let them feed into these collaboratives.
The one key, though, since these pilots or initial efforts are in different utilities, we'd be concerned operating throughout the whole state that we don't want to wind up on a fragmented basis. What worked well in Central Hudson's becomes the Central Hudson standard versus what's done in Brooklyn, Queens becomes the Con Ed standard. That's not a desirable outcome either.
Follow up to Greg's question. You know, in terms of providing data, you know, the other things I'm mindful of, as I've heard from a lot of participants, is everyone's getting pretty worn out about all the activities that we have to try to get this done. Would it make sense if we're going to be looking at, for example, the standby charge components and how to reprice and think about standby charges and this data issue? You know, I get concerned as there's too many different groups, and then we have potentially conflicting answers. Does that seem like we should be thinking about those as sort of one set of issues or a subset of one? Because thinking about what data you provide, how much that's going to cost, what you want to create networks, and then how you create standby charges or access charges to go with it, strikes me as a fairly, if they're not the same issue, they overlap at some level. I'd be kind of interested in your thoughts on that.
Well, Audrey, I think, and I forgot who mentioned in the first panel, was this overlap that occurs between Track 1 and Track 2, and to the extent that we are making decisions in Track 1 that somehow prejudge what Track 2 has to do, or we're making in a vacuum, I think you're right. I think we have to at least be aware of where there could be overlap and figure out the best way to address that, so we don't get to an answer at Track 1 that somehow we haven't factored in the result in Track 2, and now we can't move forward because they're not congruent, or we're not happy with the outcome. So I agree with you that at least, you know, standby rates is probably something, as we do look at
greater penetration of DERs, we have to understand, again, what are the performance requirements for these resources, how they're going to be treated, how they're going to be compensated, are there penalties, and then ultimately, what are the other tariff implications for these customers.
I think that from our perspective, I view standby rates as just one other component of the price signal given to the DER provider, and based on the attributes of the underlying DER, honestly. And in a perfect information sharing environment, you'd have surgical standby rates based on the individual DER deployed. So I think it's about incremental learning.
Just on that note, I think it's sort of like we don't want this to be the game of Candyland where you get to, right, the last move, you think you're about to get to the castle and you wind up pulling the gumdrop and,
I guess, Diane, the only thing I would say is that we're going to learn through this process, right?
And I cheated in Candyland, so.
And I think what's important is that we learn from our experiences, and hopefully the experiences are going to provide us better insights to, I'm sure mistakes will be made, right? Not purposefully, but we will make some mistakes. But we should be able to say, well, this is not going to work, and we need to be comfortable making a change in that decision. So, but that doesn't mean we should be sitting around waiting till we get done with track 2 before we move forward. And I think we can move forward and mindful of the fact that not every answer is going to be probably right, and not every decision we make will be the correct one.
So I just wanted to follow up, Kevin, first with the DMCs. How often do they need to be updated? And what I'm thinking about is, we talked about a short-term problem where a feeder is out for a short period of time, but mostly we have longer-term problems where you're talking 2, 3, 4 years out.
I think it depends on the user, honestly, and I think DMCs can be used in 2 or 3 different ways. So the stakeholders on the planning side want to see DMCs published based on the amount of time or lead time they need to determine where capital should go or how they should interface with DER providers to give them capital signals to make decisions on deploying hard assets, whether it's reconductoring a line or moving load from one substation to another, or providing a signal to give folks a chance to come in and, in a DER perspective, deploy storage or solar or other types of assets. And the other one is the frequency with which DMCs are updated should be based also on the market appetite for moving load back and forth through that mechanism. So not necessarily different from the ISO environment, where if you have AMI or you have telemetry that informs a refreshed DMC on an hour-ahead, day-ahead basis, you can clear certain levels of capacity based on that. But I think it all starts with longer-term load forecasting at a very granular level, and then moving and essentially layering on the ability to do things more quickly.
So speaking of AMI, can each of you just touch on how necessary you think that is in order to achieve the goals we're trying to get with REV?
Sure. Yeah. So from our perspective, AMI is an application. It tends to be a very important application relative to getting started because it fosters the underlying network. There can be debates about how valuable it is as a standalone silo, and I may be inclined to agree with both sides of that. However, once that network is deployed to the edge, it becomes highly valuable for things like, how well the grid can operate, beyond, just reading meters. What load disaggregation services can we provide? Can we use that network then to reach into the home and do things like demand response? Can we use that same network to, better control devices on the grid? So from an AMI perspective, if you just want to talk about AMI, that's kind of one debate, but our perspective and our point of view on it is largely, it's foundational, and it can be leveraged for other things far into the future. You don't rip it up and replace it every 10 years. You leverage that investment over time, and the more applications you stack up on top of that, the better it is for the ratepayer, because they're not continually consumed with, a whole bunch of siloed applications that just continue to cost, and functionally maybe do some of the same things, underneath the plumbing as I alluded to before.
So putting on the RESA hat, AMI, well, expanding hourly metering is good across a whole number of spectrums, both in terms of the commodity settlement with the ISO, getting customers to be able to be rewarded for changes in their behavior, and also for measuring DER participation as we embark on this distribution marginal cost valuation. So whether we put everybody on an AMI or whether we just expand the amount of of hourly metering. I think that's really a cost-benefit question that is a function of how hard is it to get full saturation of hourly metering. And I'm not in a position to address that question. But I did want to come back to how often should we update the distribution marginal cost. I think that's a function of how often are we procuring or resetting the supply stack, right? Because, there'll be different, whether it's an annual refresh of the DSP going out and saying, I need to engage and contract with and at least identify a group of resources. Every time that sort of time step is done to solicit or enroll or sign up or contract, depending on what the mechanism is, then we want to either affirm that the previous set of marginal costs are appropriate or that they've changed because we already have some commitments from a certain number of suppliers. So I would almost say we need to figure out how is the DSP going to be interfacing with the DER providers in order to answer the how often do you refresh the marginal costs.
And while there's probably not a consensus among the utilities with regard to AMI. I'll just give you from Central Hudson's perspective. Again, I think when you look at where the load is concentrated, there are a few number of customers or small percentage of customers that concentrate a majority of the load. So do I need hourly data from every one of the endpoints in the system? And our position is no. With the model-centric approach where we now can model the distribution system very discreetly and have information from key nodes on the system and endpoints on the system in terms of voltage and currents, we know with great accuracy what's going on in the system and have the ability to measure that and make decisions without having all that endpoint data. And at the end of the day, if there's a cost benefit, then we would be supportive of that. But again, I think at least initially, it's not something that we see as critically necessary in order to enable the markets.
I'm going to interject, and Larry, I'll let you answer the question. But then it just seems to me then there's gets back to my previous question. From the distribution utility perspective in terms of running the system, it sounds like, Paul, you're saying you don't need this all over the system. If you're an ESCO representing a company in the market who's trying to participate, Steve, you're saying it'd be really hard to, if you can't do hourly settlements, to get the full value. So then it gets back to my question is, how do we then adjust the recovery of those costs? Because it doesn't, to a certain level you would say this should be socialized because it benefits everyone, and to a certain level, at a certain level of penetration, it seems like it's not necessary for everybody from a system perspective, but may be great for an individual.
Well, the current approach, where if we want to get customers who are not currently hourly metered participating in these programs, we have to pay for metering, and so that creates a barrier to customers participating in the program because they've got to have enough value to overcome that new metering set point. We can go down that path, but arguably that's a suboptimal solution because you'll have some customers who might otherwise be willing to participate but see that metering cost as a barrier. The hard part is to parse out what are the aggregate values of AMI. It can be, improved information to ESCOs. It can be improved information for the REV proceedings. It can be improved information for the utilities responding to outages. So there's lots of beneficiaries. So it's kind of hard to say, okay, we upgraded the AMI Con Ed solutions. You've got, 30,000 customers who benefited from it. You pay, 30,000 out of 3 million of the costs. It's hard to sort of allocate things explicitly that way.
Yeah, the only thing I'd add, Audrey, is that the approach the Commission has taken with, kind of dropping down tiers in terms of customers with higher usage, I think is a great approach. I think that provides more granular data to both ESCOs and the utilities, but does it in kind of a strategic kind of approach, and hopefully that provides better information to the ESCOs as well in the settlement process. And again, I think that approach has worked well and maybe something that could be continue to be pursued.
And the only comment I would add, and I agree with what has been said so far, is that, the issue of AMI, as we've seen it in Europe, for example, is one of the things where every utility may come at it from a different angle. And when they do their cost-benefit analysis, some utilities see it as a benefit for the system. Others see it as a benefit for the consumers in terms of their ability to access what we're calling here the DSP. So I think I agree with Paul that, perhaps it may not necessarily be it's not necessarily a must-have in some instances, but I think depending on the system and the types of services you want the DSP to offer, the types of products you want to have in place will require whether or not you need to go as deep down in terms of touching the customer or remain at the feeder level. So I think this will depend on, that's why I say in my remarks, my written remarks was that it all depends on what services you want to be provided. Some services do not require that level of granularity, perhaps, others may. So it's not something I think should be a must-have, but it should be defined by the services you want to provide.
And I'll go back to kind of that foundational network discussion or point I made before, is such that, in Paul's case, he may just want to or need to, look at a subset of his customers in that manner. However, from Steve's perspective, hey, look, in order for me to function well in your service territory, I really kind of need those other things. So there may be a balance here relative to how those endpoints are enabled, but having the foundational network in place allows it to happen. Because if you don't have that, then again, we're back to this siloed thing where, utility A may be doing one thing to hit their needs, and others who want to enter the market may not be able to get the amount of data that they want because the infrastructure isn't there. It's, again, very chicken and eggy. I think it came up before. So from our perspective, you start with the network, and you kind of figure out how you might be able to build on it, from instance to instance. And then once it's there, again, it serves purpose beyond AMI. That's why I really wanted to make the point that AMI is an application. It's kind of not the be-all, end-all of what we're trying to get to.
No? All right. So, well, thank you all. I think we're at the end of our time.
We are. We have a 45-minute break for lunch. There is a large cafeteria on the 3rd floor for people to eat. They don't want to go outside. And staff who have paid in advance can take it in the back.
All right.